In this video, we're going to go over how to find the domain and range of a given function. Most of these are going to be functions. There could be some that are not functions. The procedure is the same, but we're going to focus on functions. So you can find the domain and the range if you know what the equation looks like, or if you can find or graph the equation of the function. You can also find it if you're given the equation. So the first thing we're going to look at is how to find the domain and range of a line, or a function whose graph is a line. So you get the domain by the permissible replacements of x. You graph a function, you're going to get a graph that's made up of ordered pairs. So if you look at this line that slants like this, which means it has positive slope, if I go back over here to the right and pick any x, I can go as far as infinity is over here, minus infinity is over here, and this line goes on forever like this and like this on this side. Pick any x, you'll get a y somewhere up here. Pick any negative x, you'll get a y over here. There's no restriction. This type of line is a function. For every x, there is just one value of y. In other words, if you draw any vertical line anywhere where the line goes, the vertical line will intersect the graph at only one point. Whereas in a circle, you draw a vertical line, or inside the circle it's going to cross at 2 points, so that's not a function. Circle is not a function, it's a relation. So in something like this, you can pick any x and you're going to get a y. So we say that the domain is all real numbers. That's the term we use, or the phrase we use. Or in interval notation, we say negative infinity to infinity. Now for the range, you pick any x, is there a restriction on the y over here? Notice if I go along the y-axis, pick any y, there'll be somewhere over here, there'll be an x. If I go down the negative side, there'll always be an x corresponding to it. So for the range, again, all real numbers. Or in interval notation, negative infinity to infinity. Now this doesn't matter if a line slants this way, same thing. Domain, negative infinity to infinity. So any equation that determines a line that's either slanted in the positive direction or the negative direction, the domain will always be negative infinity to infinity. The range, negative infinity to infinity, or all real numbers. Now what if we have, let's say we have a horizontal line. This goes on to infinity this way, and let's say this is 1, 2, 3, 4, 5. So this is a horizontal line. The equation is y equal to 5. Notice a vertical line crosses the line at one point. So this is a function. A horizontal line is a function. So I can pick any value for x. If I pick x to be 1, the y value is 5. If x is 0, the y value is 5. If I go over here to negative 3 for x, the y value will be 5. So the domain, negative infinity to infinity. The range, notice for every x that I pick, I always get 5. There's only one value in the range. So in this case, I just set up a set with one component. For every x, the y is always 5. You got that? Now let's suppose we have a vertical line. And let's suppose the equation of this is x equal to 2. So 1, 2, and then we draw the vertical line. So notice x is always 2. So at this point, if I go 1 point up there, that's the point 2, 1. I go 2 up, that's 2, 2. Go down over here, that's 2, negative 1. So x is always 2. The y varies, goes from plus infinity to negative infinity. So the domain, just the opposite of what we had for the horizontal line, the domain consists of one component, that's 2. And the range, again, goes from negative infinity to infinity. Again, this one is not a function though. A vertical line is not a function because if I draw a vertical line on top of this line, it intersects it at an infinite number of points. So it's not a function, it's a relation, but a relation can have a domain and a range. Now, let's look, and just for that then, anytime you're given an equation, so let's suppose I give you an equation like y equal to 3x plus 6 you should recognize that an equation that has an x to the first and a y to the first, not a y squared or a y cubed, just x to the first and y to the first, that's always going to be a line. And as long as it has an x and a y, it's going to be either a slanted line going in the positive direction or a negative direction. So the domain and range will always be the same. All real numbers are negative infinity to infinity. If you just have a y equal to a number, say k, that's a horizontal line. The domain is all real numbers. The range will simply consist of one component. The y is always k in this case, whatever it is, 3, 4, 5. Now let's look at your basic parabola with vertex at the origin. So let's say that point right there is 0, 0. That's the vertex. Know what the graph of that looks like. So let's say you're just given the graph. You don't need the equation in this case if you're given the graph, but let's say the equation of that is y equal to x squared. So again, that goes on forever that way and forever this way. So the domain, x is 0, y is 0, x is some positive number, y is some positive number. I can go way over here, I get a positive number, I go way up to the graph, y will be positive. Same thing on the left side, so the domain will be all real numbers, or negative infinity to infinity. No restriction on the x, it can be all real numbers. But notice the graph of this parabola stays above the x-axis. So no matter what value you pick for x, the y value has a minimum value of 0, and then it increases. So right here is 0, and from then on it increases. So the way we denote that is the range for the y value. Minimum value is 0. Bracket here means that 0 is included, 0 to infinity. Now sometimes they'll give you a graph, and maybe they'll give you an open circle right here, right at the origin. Let's say they had an open circle. That means that point is not included. So that means the point 0, 0 is excluded from the graph. So in this case, you don't include the 0 for the range, and you would also include the 0 for the domain, because 0, 0 is included. So you have to eliminate the 0 for the x and 0 for the y. So in this case, you would write this as, you can say all real numbers except 0. But if your instructor wants you to write it in interval notation, then you would include it negative infinity to 0, union 0 to infinity. Again, that means every real number except 0. Everything's included except 0 if they write it this way. So know what the graph of this looks like. It's a parabola, y equal to x squared. And again, we could use, instead of y, we could use f of x to indicate it's a function. So just know that if we add something to this, let's say we add a 3 here, the same graph except it moves up 2. The y value increases by 3, so it's a 0, so we go 1, 2, 3, and then the graph goes up like that. There's still no restriction on the x. X can be any positive number. At 0, x is up here, it goes to 3, the y value is 3. So for this one, the domain, all real numbers. So we can use the words all real numbers, or if they wanted an interval notation, you could use this. As far as the range, again, the smallest value for the y value is 1, 2, 3, and then it increases. The 3 isn't included, so I put brackets here. This is 3 to infinity. So just to review, if you know you have an equation of a line, and you know the line has a positive or negative slope, the domain and the range are always going to be all real numbers, negative infinity to infinity. If you have a horizontal line, then you know the domain is all real numbers, negative infinity to infinity, but the range will be fixed. If it's y equal to 5, y equal to 6, the range would just be that value. And it's just the opposite for a vertical line, x equal to 3, or x equal to 5. The domain stays fixed at whatever it's equal, and the range is all real numbers. Now also know, if you got something like this, y y equal to, say, something x to the third in this case, or f of x. It could be f of x. So notice if x is equal to 0, at that point, if x equal to 1, y value is 1, because 1 cubed is 1. Okay, go to the other side, negative 1, and cube it, I get negative 1. So just with a few points, you can see that the graph of this looking something like that. So you may be given the equation, or you may be given the graph. So you can see here, this graph goes on forever that way, this way. So I can pick an x way over here, there'll be a value for y over there. Value way over here on the left side, this goes on forever. So it comes down this way. So the domain, negative infinity to infinity. Same thing for the y. The range equals the same thing. So I want you to notice here that whenever you have a polynomial function, and the exponent is odd, in this case it's x to the third, or it could be x to the fifth, and then it could have some other terms. But it would be, say, odd degree, degree 3, degree 5, degree 7. It's always going to go something like this. Now it could have other loops, so it could go like this, and then go up like that. So if this is a 3, a 5, a 7, a 9, you can have several terms over here in the middle here. The domain will always be negative infinity to infinity. The range will always be negative infinity to infinity. So any polynomial that you have, whether it's degree 7, degree 8, 2, the domain is always all real numbers. The range will be all real numbers also if it's odd degree. Now if you got something like, say, y equals x to the fourth, if you have even degree, 4th degree, 6th degree, 8th degree, and so on, then in that case, your graph, depending on the degree, might look something like this. Domain will always be all real numbers for a polynomial, but the range might not be if it's even degree, because it's not going to go down and up. Even degree, they go like this. So in order to find the range, you'd have to know, say, this point here. If this is the lowest point on the graph, you have to know this. Or if this is one that is the lowest, then you have to know this one. Now, if you have a log function, let's say this is log of x, it could be base 10 or base 3. Let's say it's base 2. You should know that the graph is going to look something like this. See, this expression right here cannot represent a negative number, so x has to be greater than 0. That's one restriction. So that means the graph is going to stay to the right of the y-axis. So it's going to come to the left of 1. The log of 1 to base 2 is 0, because 2 to 0 is 1. So the graph stays over here. So the domain for this has to stay to the right of 0, the x, not include 0, so that's why I put parentheses here, and then it continues forever, so this goes 0 to infinity. And notice the graph continues this way, stays to the right of the y-axis, and it goes up forever. So the range in this case will go from negative infinity to infinity. So if I make this a 3, pretty much the same type of graph. Let's suppose I give you this, the log of, say, x minus 5. And if this value is larger than 1, got 3 there, let's say that's 3, then it's going to look kind of like this one. But you got to remember that you can't take the log of a negative, so this x minus 5 here has to represent a positive number. So that means that x has to be greater than 5. Because if x is, say, 3, that's a negative 2, undefined. So in this case, the graph will look pretty much the same, except it's going to stay to the right of 5. So go 1, 2, 3, 4, 5, and it's going to have everything is shifted to the right. And the point that was here moves over here to 6, because notice if I put a 6 right there, 6 minus 5 is 1. The log of 1 to base 3 is 0. So the graph would cross something like this. So the domain, the 5 is not included. The domain would be from 5 to infinity, and the range goes out that way, comes down this way. The range is still the same. So for this particular one, we have this. So like I said, you can get the graph if you have, you can get the domain, the range, if you know what the graph looks like, or you can graph the expression. And it's fairly easy for the most part if you're given the equation of the function. So let's look at these here. Let's look at the first one. So applying some of the ideas that we just went over. Here I have a polynomial with degree 3. So a polynomial with degree 3, I would expect the graph to go up on one side and down on the other. So this would go something like this. So let's see, replace the x by 0 here. I get -8. So the graph is going to cross the y-axis over here somewhere. So all I know is that it goes something like this. It could have several other loops. So this point down here would be 0, 0, -8. 0, -8 is the y-intercept. But the only thing you really need to know to determine the domain and the range is that it goes up on the right and down on the left. Now if this were a negative here, if this was a negative x to the third, then it's just the other way around. It goes up on the left and down on the right. But either way, the domain is always going to be -infinity. As long as it's a regular polynomial function, the domain is always -infinity to infinity. And if it's odd degree, this is say a 3, a 5, a 7, a 9, the range will always be -infinity to infinity. Now this one we kind of already did. This is a parabola here. You should recognize this is a parabola, f of x equal x squared. So because it has the 2 here, it just moves up 2, and then it goes up like this. So without the 2 here, the vertex is at the origin and it opens up. So the domain, obviously this is a polynomial. So any polynomial will always have domain of -infinity to infinity. In other words, there's no restriction on the x. You can pick x to be any number and you'll get a point on the graph. Now the vertex is at 0, 2, and the graph opens up. So the smallest value of y is 2. So we say, okay, the range, and the 2 is included, so we need brackets here. You only put parentheses if that number's not included. So this would be a 2 infinity, and that's your answer for that one. And of course this one, we just pretty much did this one. It's a log. You can't take the log of a negative. So start by saying, that means that x minus 5 has to be greater than 0, which means x has to be greater than 5. Solving for x. So the domain, and the 5 is not included, the log of 0 is not included, so I put parentheses on the 5, and then goes to plus infinity. And this is 5 over here, and the graph's going to go something like that. So it's similar to the one we just did, the first section. Range goes from -infinity to infinity. So domain, any number larger than 5, range, numbers from -infinity to infinity. Now let's look at this one. If you got a square root, the thing you have to remember is you can't take the square root of a negative number. For domain and ranges, we're dealing just with real numbers. If the number, you got a negative under the radical, it's an imaginary number. So we want to know then what values will make x minus 2. Now you can take the square root of 0. So basically kind of like with the logarithm, except in this case we can't include 0. X minus 2 has to be greater than or equal to 0, which means x greater than or equal to 2. So you can pick any number here and it'll be defined as long as it's 2 or larger. So the domain would be written this way. And if I were to graph this at 2, the value is 0. And then if I pick a number larger than 2, I'll get a positive number. Square root stays positive. So as long as I pick numbers greater than or equal to 2, I'm going to get positive y. So the graph is going to stay above the x-axis. What values of y make up the range? Well, the smallest y value is 0, and then as I go to the right, the values keep increasing. So for the range, it would be any number greater than or equal to 0. Do it like that. Those are your solutions. Okay, let's look at f of x equal 3 to the x. Now, if you have the equation, all you have to do for the domain is to see if there's any restriction. So now I have 3 to the x. So if I take 3 to the 0 power, that'll be 3 to 0 is 1, 3 to the 1 is 3, 3 to the 2 is 9, 3 to the -1 is -1/3, and so on. Do I have a restriction? Is it undefined? In other words, you got something like this, 1 over x. If your function looks like that, y is equal to 1 over x. That's easy. x can't be 0. So the domain for this one is anything except 0. Look at this one right here. 5 over what? When you got a fraction, the thing you have to be aware of is you cannot have a 0 in the denominator, so you can't plug in a value that makes this a 0. Another 4. 4 minus 4 is 0. Can't have that. So for this one right here, the domain is going to equal to all real numbers, or negative infinity to infinity. In other words, you're just taking this to a power, whether it's a positive power or a negative power, no restriction. We don't get something that's undefined. And if you just pick a few values here, say pick a 0 here, I get 1 right there. Pick a 1, 3 to the 1 is 3, I get 3 over here. So you can see that if I pick positive numbers, the values of 3 to the x keep growing. So that tells me then that the graph is going up something like that. Whereas on the negative side, 3 to the negative 1 is 1/3. 3 to the negative 2 is 1/9. 2 to the negative 3 is 1 over 27. So if I pick negative values, the y value keeps decreasing. So the points come like this. But it never crosses the x-axis. So the range, you gotta get close to 0, but not quite there. So we put open here, parentheses in, and the graph stays above the x-axis, 0 to infinity. And that's what we have. And this axis, the x-axis, which has equation y equals 0, actually represents a horizontal asymptote. So you know what this looks like, the graph. So you should know then that if I make this y equal 2 to the x, say plus 2, the graph is going to look the same, except everything moves up. We're adding a 2 to the y value, so everything moves up 2 units. So instead of having the asymptote here at y equals 0, I'm going to have it at y equal to 2. So the domain is still going to be negative infinity to infinity, but the range will go from 2 to infinity. Same thing if you had 3 to the x plus say 5. So learn the basic one, and then know what happens when you add something. Shift the graph up. A negative, of course, we shift it down. Now, let's look at the next one. We already said the domain for this one. If I use set notation, again, the only thing you have to watch out for is there a number that makes this denominator 0? If there isn't, then it's all real numbers. Now, if I make this a plus here, if I make this a plus and a square, now, no matter what I plug in for x, the denominator is always going to be positive, so in that case, the domain is going to be all real numbers. But if I leave it the way it is, so in the set of all x, such that x does not equal to 4, because 4 makes that denominator 0. Division by 0 is undefined. So you could write it this way, or you can say, or you could write it in, you look at it this way, in the number line, say this is a 4 here, and I exclude the 4, so I have an open circle here, and then it's everything on this side, everything on this side. So in interval notation, this would be negative infinity to 4, union 4 to infinity. Now, you could go ahead and sketch the graph if you wanted to. Fine, this one has a vertical asymptote at x equal to 4. And from the graph you can find the range. Or you could do this. Let's make this f of x, instead of an fx, let's make it a y. So in other words, what I'm telling you is if you have the equations out for f of x or for y, just look at the right side. And if you can replace the x on the right side by any number and not getting, say, division by 0 or a negative number under a radical, generally it's going to be all real numbers. Or if you can solve the equation for x, so here's what I'm going to do. I'm going to multiply this one. In other words, solve it for x is what I wanted to say here. So I'm going to multiply both sides by x minus 5, and all I did here is replace the f of x by y instead of writing out the f of x. And then over here this is a 5. So multiplying by x minus 5, sorry, x minus 4. This cancels out, and then I get this on the other side. So let's see, this is going to be yx minus 4y is equal to 5. So the original one is solved for y. All I'm going to do now is solve this one for x. So I brought added 4y to both sides to isolate the x term, and then I divide both sides by y here. I want to isolate the x. So this tells me that x is equal to 4y plus 5 over y. So again, if the graph is given, you should be able to identify the domain in the range. Or if you're able to sketch the graph, you should be able to see what the domain in the range is from the graph. If you're given the equation and you don't want to mess around with the graph, then again, like this one here, all you have to do then, this one's solved for y. And we know on the right side, we can't have a 0 in the denominator. What number makes the denominator 0? 4. So the domain is everything except 4. And here's the result in interval notation. Now, if you're able to solve for x, sometimes it's a little bit difficult to do it. So you have to look at the graph. But see here, it was pretty easy to solve it for x. And then you just look at the right side. Over here, we want to see restrictions on x. What's the restriction in y over here? What number can I not use for y? Is there a restriction? If there's not, then the domain is all real numbers. But notice you have a y in the denominator. Division by 0 is not defined. So the range, the set of all y, such that y cannot be 0. If I write it in interval notation over here like this, it will look just like this, except instead of a 4 here, I would have a 0 and a 0 over here. In other words, we're excluding the 0 from the range. And that'll be it for the video for today. Thanks for watching. We'll see you next time.